Your data is being classified in terms of two classes, right? So you are being classifying your data when you are changing the neighbor value as 2, or if you change this one as 1, so definitely it will come to some other, so which you can see, right? So like that we can change the nearest neighbor values. So the nearest neighbor values will be changing as per the classifying the data in terms of the required information, that is as per the KNN value. Now after classification, if you want to calculate the regression of this, that is what are the target of the features are extracted, then what we are going to have is that we will do this regression of type for one of the data set, for another data set. So for that data set we are going to see now how we are going to extract the information, that we will see now. So now I am taking a data set which is called as the importing data set of wave samples. Okay, I'm going to take a data set now. So this data set is nothing but which is going to do the operation on the samples what we are having. Okay, so that we are going to write a program. So what we are doing here is that now we are taking a data set. Okay, so this data set is nothing but of data set of wave samples. We have drawn the wave also. A sine wave is being generated now. In the same way, in the sine wave generated, we are having the samples now. So those are in the same way that data set is taken here. Data set of wave samples are taken, and we are calculating the regression. That is, regression is nothing but showing in terms of some targeting continuous target that we want to extract. Okay, so what we are going to do is that we'll be taking import mglearn import my, we want to plot the regression. So what we are taking is now we are changing the data set. So what is the data set that we are taking here is that make underscore wave. So in this wave is nothing but a signal that you are having. So for this signal, what are the samples that we have? 40. For example, we were having a 40 samples of data which has been available. So x and y are common only. X is being considered as your input and y is considered as your output operation. What we are doing here. So x and y. So we want to plot the data now. So when we want to plot the data, how we are going to plot now? Right. So we are going to plot the data now. So in order to plot the data for x comma y, that is mglearn.dataset. When we want to plot the data, what we are going to do? So in order to plot the data, you want the input x and you want the y output, what we want to have. So for that, what we are going to do is that we are going to have the plotting now. So we'll let's do the changes in the plotting. Okay, we'll do the changes in the plotting. So how I write is that plt dot plot in terms of our input is capital X comma small y comma I have denoted a function that is of O, that is just to indicate, right? In the same way, I want to have the labels that plot dot y limit in terms of minus 3 comma 3. So I want to have the plot in the y-axis within the range of minus 3 to 3. Plot x label features. So I have asked the plot of x label as features. Plot y label as target. So I given this that I want to have a plot that has to be given for my data set, which is consisting of a wave data set with samples of 40. 40 within the 40 samples I should get the result, and that result has to be shown to me. Okay, that is the thing. So these two lines which I'm having is doesn't require now, because I'm not doing for another same data set, no? So we are doing for some other. We have not yet implemented KNN, just we are running the program. Okay, we will see what is the result we are going to get. So when you run the program, you can see very clearly that you are going to get the result which is consisting of the limit range. You can see target and on the y-axis and features on the x-axis from minus 3 to 3 and minus 3 to 3, and you are having the values of those data set which are being shown here. Those data set values are being given in terms of 40. If you count all this, you'll get only 40. All the samples are being sorted in terms of 40 values. That is the thing, right? So that is the extraction of the output how we want without using KNN. Don't forget. Right now we have not yet used KNN. Just we have implemented that. Right. So that is your regression. That is regression. How we are being generating. Now we will be doing another one that is for some forg data set only in terms of a different manner. So I will be showing the slide. So this is the information what we got. We've been giving the samples and we are trying to find out the regression in terms of those samples. So we have been getting that, right? So we have seen this also, that is the k nearest neighbors implementation for the same dataset, for the forg dataset, where we can change the kn value equal to 1 or 3 also. That is possible. Okay, so we can do that. So we change it to 3, then the result is been changing in this manner. So the classes are divided in terms of two classes, class 0 and class 1, right? Which is being shown here. Next we are doing the say k neighbors classifier, that is this k neighbors classifier of two-dimensional data set that we want to extract is being shown here, which has been given, and this is being shown only for your information of the forg data set only. Don't forget, it is not somewhere, it is of forg data set only, right? So for the forg data set only it is being shown. So we are taking the mglearn matplotlib, and we can see that from sklearn we have asked them to generate a classifier here, import k neighbors classifier, k neighbors classifier. So we have asked that. So it has been creating k neighbors classifier, and we are trying to have the plot in terms of this one, that is subplots. If I want subplots to be generated, so that subplots are being generated here with a size of 10 and comma 3. What is this figure size? Is nothing but length This is your breadth what we are having. That is we are being showing breadth. Okay, this is your length what we have. That is length is nothing but in this format, and this is your width. This is the thing. In general, this is length and this is breadth in rectangular shape when we call. But it has been taken here in this part, that is the total length what we are taking. This one is taken as L, and this is taken as breadth here. Breadth is nothing but width which is been taken, and this is 10, and this is maintained as 3. Okay, like this. So that is the indication of that. Okay, so we are taking the size of the figures, how much should be there, and we are asking k neighbors classifier. That is take the function of k neighbors classifier, and we have been asking n neighbors equal to n neighbors fit x comma y dot fit x comma y. What this indicates is that we are asking to fit the data of x comma y values in this neighboring, and that has to be classified with the help of knn classifier. So we are asking you to plot that. Okay, so that is the thing. So when we are asking you to plot in terms of this function, how you are able to plot that? That is the thing what we want to know, right? So what we are going to do is that we'll be running this program. Okay, so when we are running, we are being given that we are been importing this libraries what we require. Import mglearn, import matplotlib, scikit-learn, sklearn, and everything. And we have asked for the location also in the location 3, that you should get the classes that we are divided. Okay, so it is doing some operation and you are going to get the result. So we have given the neighbor values in terms of here clearly 139. So neighbor 1, neighbor 3, and neighbor 9. What are the neighbors that we have? Those all are being brought. Neighbor 1, 3, 9. What we are having. So all these are being brought up. So that is the thing. So that's why we have been implementing that in terms of in this manner. That is 139, and it has been creating the plot in terms of scatter plot. We are asked you to create in terms of scatter plot, and it is creating the scatter plot, right? So this has been shown. Don't forget we are taking a for loop here. This for loop is nothing but already we have written this. Only new statement what you're getting is mglearn in terms of two-dimensional separator, where we are asked to fill with true, and epsilon value is zero point 0.5 and alpha value is zero point 0.4. So what these indicate is that these values of zero point 0.5, epsilon zero point 0.5 and alpha equal to zero point 0.4 are nothing but values that are being given in standards and that we have to follow. Okay, so we are asked the dividing of information into two classes, so x of 0 comma 1, and we ask you to print that neighbors related information with boundaries. So it has been printing that information, but the location here we have given is a location equal to 3. So I told you in the location 3 you'll be getting the legend, that is class 0 and class 1. So this is one way of k numbers classifier implementation what we are doing here. So if you want to calculate the same thing we have seen already in the previous case, that is the for the sample data set. Just now only we have seen for the wave data set. No? For the wave sample data set we have seen in terms of number of samples that you are being generating, right? Right, number of samples that are being generated. The number of samples that are being taken here in terms of the generation now, that we are being doing once again. I'll take the data set of the samples and we'll do the program. So what this indicates is that capital X comma small y equal to mglearn dot data sets dot make underscore way of n underscore samples equal to 40. Okay, so we are creating a data set. We have read the data set. Now we want to do the plots of that. Dot plot underscore knn underscore regression of n underscore sorry, n underscore neighbors equal to 1. Plot comma y comma plt plot y limiter of minus 3 comma 3 and plot x label features plot y label target. Right, now I done only one change here, the same program only. So this is nothing but n underscore neighbors equal to 1 mglearn dot knn regression in terms of okay, what we have, that is n underscore neighbors equal to 1. So if you click that, you can see the result. So we are having the data set now. Now we are showing in terms of three things: test data set and test prediction, training data. Okay, training data, test data, and what are the things that we want to show, that we are showing here, right? So that is the indication of that. You can see. So we are giving this in terms of for data set of samples only. So k underscore neighbors equal to 1, what we have given, and we have asked everyone to extract the output what we want to have. So it is being shown here. So mglearn dot plots dot plot underscore knn neighbors. So then it is of having n underscore neighbors equal to 1. Okay, so that makes to say that we are having our information in terms of neighbor values. So these are the neighbors. You can see very spontaneous. It is connecting. The points are getting connected to the stars. So there is a test prediction, and these are rounds which are been training, and this green color which are shown is the test data. So for the test data, test prediction is also being done. It is done automatically by the function itself. That is the thing in the tool. Okay. For the same thing, we are using the KNN regression. We have been going to use the same thing in terms of testing the data in terms of values, because here you are having the graph only, but what are the values of these dots that are there? To know that also we can write a program for the same data set. So what can be the program for that one is that in the import learn, you can write in terms of in this manner from sklearn. Oh, it is not writing from sklearn dot neighbors import k neighbors regressor capital X comma y equal to mglearn dot data set. I want to bring the data sets now. Dot make underscore wave of how many samples I want to show you. I have to be deciding. So I can change that. But now I am giving only 40. Only if you want, you can go for 50 also. But take some more time. X underscore train. Now you'll be getting a new one. X underscore test. Y underscore train. Y underscore test equal to train underscore test underscore split capital X comma Y comma random underscore state equal to 0. So this is the thing. So now I'm asking my data set which I'm having of samples which I'm asking to create. So now the data set which I'm having wave data set with samples of 40 should be generated. Now I'm asking to split the data in terms of training and testing with a random state of 0. So X is nothing but our input, that is training, and Y is our output what we want to have. So we are asking you to split the wave dataset into training and testing data, and reg equal to k neighbors regressor of n underscore neighbors equal to 3. So reg dot fit. What is this regression is nothing but we are asking you the model to consider k neighbors of 3 value. Okay, 3 neighboring values are to be connected to your major value. So that is the indication of it. So regression fit. So what we are asking is that x underscore train comma y underscore train, right? So we are asking you to print that, print test set prediction colon slash n with this one dot format. It is a standard thing. The first one within the w columns is nothing but it is a heading, don't forget. Dot format, everything is standard. You can't change that. Regression reg dot predict of x underscore test. Okay, so this is the thing. In the same way for your same thing of regression you will have to calculate, that is in terms of test set only. For the test set you have to calculate the regression. For this one, you will not have in terms of colon, you'll have in terms of braces only. That is in terms of dot to f. Okay, and that is also you'll be doing for your prediction of the score value, R score value. Since R score value is nothing but to generate what is the exact score that it is able to identify that we are going to generate. So that's why we are doing this y underscore test. Why it is saying okay. We have not given another function here. That is, it is showing here very clearly. We have to give a function. There is nothing but train uh, test split. What we are having. So that train and test split function has to be given here from sklearn. Why? Because it is showing very clearly. Invalid in terms of what we have. Okay, we have not yet given that one from sklearn dot model underscore selection import train underscore test underscore split. Now your error has been rectified. You can see the errors automatically. What you want to know, those errors are coming automatically. No need of going somewhere to identify your errors. That is the thing. So when you run the program, it has to show the values of this graph which is shown on the right side with by the white color graph. So this is the output. So you can see the test prediction values which you got. These are the values which we are having. The negative values and the everything on the negative values of these things. Those are being shown here. Okay. So that is the thing. So you are having R score. That R score is 0.83. This is nothing but it is the information of your data in terms of the regression. How much is the value you are getting? 0.83. 0.83 is nothing but it is a 83 percentage. If you are been multiplying with 100%, okay, it is 83 percentage that you are getting. So that is the thing what it makes you to understand. Next, for the same data set only, that is of wave data set only, you can do for the wave data set with neighboring values 139 also. Okay, and you can plot that. So just I'll run the program directly. And we'll share this presentation to you soon after. You can try them in your laptop in the spyder tool. Don't forget. Okay, we have not imported this function which is called as from sklearn dot model underscore selection import train underscore test underscore split. So because as it is not there, the train and testing, it is not able to split. Yes, you have got the graph. Right. So this is nothing but we have taken the data set of same thing only, no change at all. That is the wave data set with samples of 40 only. But we have asked that the size of this one should be 15 comma 4 and it has given that and the limit should be of -3 to 3 only n line space and 1000 reshaping of -1 to 1. Okay, so neighboring values we have given as 139. So these neighboring values are to be printed in terms of connectivity with a line. So those are being printed and we have taken the location here and the location of the best we have given. We are not given that what to be the location value is not given here. We are given choose the best location wherever it is comfortable for you. So it has taken that location and it has printed that. So this is the neighboring 1 and this is the for neighboring 3 and this is for neighboring 9. So like this it has been doing the operation and you are getting the result of that. Okay. So that is the thing. So what are the main advantages of this neighboring is that it is having most of the them the strengths are nothing but it is equivalent distance calculation. Equivalent distance is nothing but if you have four values x1, x2 and y1 and y2, you subtract y1 minus x1, okay, plus y2 minus x2, right? Y1 minus x1 whole square plus y2 minus x2 whole square root over. So all these things you are going to do, which will help us to understand very clearly how you are able to calculate the neighboring values with the equivalent distances. Calculation is very easy in the KNN. But the main thing is that the training prediction of the data is very low and very slow also. Okay, but the KNN build model building is very fast, where you can have the KNN very large and the prediction is very slow, which has been there, and many features in the dataset may not perform well to extract the information by using KNN for all the datasets. For some datasets it may work perfectly, but some datasets it may not work perfectly. So that is the problem what they have find it out. So that's way datasets. For images type of datasets, they'll be not using this. They'll go for some other datasets. Okay, so that is the thing. So the next one what we are going to see is nothing but we'll be seeing in terms of another function that we call it as a linear function. Okay, linear regression or ordinary least squares. What we have, you can see is here. So this linear regression or ordinary least square is the simplest one where it is used to calculate or to minimize the mean square error and also for the prediction of true regression. It is used for reducing of mean square error. So we have been writing the same program only with the small changes. That what we are doing is that we have taken NGLer, we are taking the linear regression and we are asking you to implement on the data set with samples now as 60, and we are asking you to give in terms of a random state of 42. Random state is nothing but a value that you can give randomly, a state value from 0 to 100 or something. From 0 to 100 you can give any value, but most of the time every time we will focus on the random state either 0 or 42. Every time near 42 they got the better result, which is understandable. And for this data set what we are taken with n underscore samples equal to 60, what this indicate is that it is dividing the samples now into 60 samples, the wave data set, and we are asking to fit the training and the X train and Y train, that is the data of your training data and also for your test data in terms of Y output trained data both into your linear regression, asking you to print them. So when you run this, it will show in terms of numericals what is the linear coefficients and what is the linear intercept values that you are going to get. Just the linear coefficient and the linear intercept values are being getting for you here. Simply, we have taken the data set, we have split the data set. So the initial the three are your libraries for your linear regression to import from sklearn. How you have to write is linear underscore model, and also in terms of train and the testing split. So this is the linear intercept value, slope and the intercept values that you are going to get them, right? So what can be the training score and the test score that we are going to get for this program? So the trainings, because as you are splitting the data set into training and testing, now we are giving in terms of print underscore, sorry, brackets in terms of training set score in terms of this, what we have in terms of dot 2ef dot format, which one you want to have, lr dot score in terms of x underscore train comma y underscore train. In the same way, we are writing the same statement of print only for your test. 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 We'll run the program. See, you are getting. So your training score, what you are getting is 67%. Your test score is 66. Your coefficient value and the intercept value, so you got. You are being getting the training score and you are getting the testing score. What we are having here, right? So this is one type of linear regression. What we are been having. We'll have the continuation. Why? Because there is both are equally nearest. It may cause for overfitting or underfitting. So that we want to overcome. That we'll be seeing by using the linear regression only. And after that, we'll go for the ridge regressions. Okay. These all we will see tomorrow. Okay. Then we'll close the things and we'll go for the support vector classifiers. Okay. We'll see all these things tomorrow.